So I'm really excited for this webcast. This is something I have been wanting to do a presentation on for quite some time. We have been running a lot of new user training for all disciplines of Revit, and the bulk of the topics you're going to see here today are things that I think are super important for any new user, but due to a number of reasons, just don't get covered in our 3-day new user course. Now, that being said, even if you have not taken our new user course, are completely new to Revit, or have been using the software extensively, please stick around with us today because I will try to mix in something for everyone. Even if you have been using Revit for years, you might pick up at least one or two things you didn't already know, and I've got some other goodies to send your way as well. All right, so I plan to start with an overview of the 3 kinds of Revit families, then spend the bulk of our time talking about component families and some of the great things that we can do with them. I will leave you with some resources and links, and I promise to leave some time for Q&A. The last 2 presentations I did ran right to the very end, and I think some questions got left on the table. So I plan to do a hard stop around the 45 to 50 minute mark today so we can allocate time for any questions that didn't get answered in the question panel. All right, so as I was saying, this topic really is super important because Revit families are the backbone of every single Revit project. So here is a list of the 3 kinds of Revit families. We have component families, system families, and in-place families. All right, so let's take a closer look at all of these now. Component families consist of items like doors, air handling units, columns, plumbing fixtures, lighting, tags, and even symbols. They are defined, built, and modified in a special family editor inside of Revit and can be loaded into any Revit project, template, or even nested inside another family. These can also be saved independently as an RFA file and stored outside of Revit. Revit actually installs with an extensive library of components, but it is not uncommon for users to build their own custom content and even download free content directly from the manufacturer of the products that they plan to spec, or sometimes, something close enough. Okay, so this will allow users to accrue a vast library of content. And as a side note, if you are curious where to find manufacturer provided content, I will show you some resources later in the presentation. Okay. Now, let's take a look at system families here. These are typically preset in the template or your project files. These include things like walls, roofs, floor slabs, ducts, pipes, conduit, cable tray, and even text and dimensions. One of the cool things is that they can incorporate one or many different component families and stitch them together as a single working system. For example, in a run of ductwork, we need multiple different families to create one single duct run. For any one run of duct, you might need the standard duct family, some elbows, T's, and reducers. But we have several families loaded for each of those. What the system family will do is act as a container of sorts, or a parent family, where we can assign exactly which components to use for each condition. In this example on the screen, you can see a continuous run of ductwork alongside the routing preferences, where we have specified what component families to use for each condition. So as you can see, these get more complicated than a standard component family, but can be shared between projects, and unfortunately can't necessarily live outside of the project environment. In other words, you can't save the whole system family out to a library location like you could with a RFA single component family. Okay, now the next one is in place families. And these are simply a family that can be built inside the Revit project environment using the standard family geometry tools. The intent for an in-place family is that it is to be used in a custom condition that does not ever need to be duplicated on another project. Now, I know some of you might be cringing a little bit. I'm going to interject some opinion at this time and say that I recommend never using these, and I wouldn't make a statement like that without at least explaining why. So the first drawback is that these families are stuck inside the project environment and cannot be saved back out to your library or modified in the family editor. You will have access to the standard geometry and materials tools, but you will be missing some of the robust abilities of component families, such as creating family types and adding parameters to flex your geometry. And there's also some weird naming conventions that happen with in-place families. But nevertheless, I am sure you will run into a place where it is tempting to use an in-place family. And as long as you are aware of the drawbacks and can live with them, feel free to use an in-place model, but just don't tell anyone that I said it was okay. All right, so now that we have a basic understanding of the three kinds of families, let's take a deeper look at component families and some of the things you can do with them. For me, the most logical starting point here is the fact that you can apply a parametric framework to your components. This opens up the opportunity to easily add parameters to drive the physical geometry of the elements, or even add any kind of critical information that you'll need for that element. In this example, I have a countertop that has a built-in length parameter so that the user can type in the desired length in the length parameter inside the object's properties, and the model will instantly adjust to the new length. All right. Now, if we look at this component inside the family editor, we can see some of the underlying components that made this possible. In the family types dialog, they created a length parameter. Then they added a dimension string to the geometry in the model. After that, they associated the dimension string with the parameter. And now we have a parametric component family. Okay, so that last component we looked at was pretty basic and was built with some simple extrusions, which is just one of the many different model geometry options. In addition to extrusions, we can also do blends, revolves, sweeps, and even swept blends. In addition to the solid geometry options, we also have a void counterpart for each of the modeling options already mentioned. So you can use these to cut out various shapes from your solid models. Using these together, you can model almost anything you might need. And especially for construction document purposes, if you need to model a higher level of complexity, sometimes I would ask the question of why rather than how, just because when we start to add too much detail, our models can kind of get a little bogged down. So let's take a look in an example of what a typical column might look like when you are modeling its underlying geometry with the extrusion command. Basically, you can use the standard pink sketch line tools to draw the geometry. And when you're done, you can see how the software literally extrudes the sketch based upon where you define the start and end planes. And I also included an image on the right side of what the final product might look like. Okay, so blends are similar to extrusions because they are also sketch-based. The major difference here is that you can have a different sketch for the base and top. Sometimes this might be useful when you need to connect two totally different shapes, like a rectangular to circular duct transition. On the screen, we see just such a component as well as the underlying sketches used to create this shape. You might have noticed that the circular sketch is in the same plane as the base. That is because you can sketch the shapes in a single plane, then use the height parameter to tell where the base and top actually go in the Z direction. Revolves also work from an underlying sketch. In this example, we have a planting urn. And if we look at how this was created, we can see that the profile has been sketched, then revolved around a center line to complete the geometry. In this case, it is set to a full 360-degree revolve, but you can do a partial revolve. For example, maybe you have a wall-hosted sconce light fixture. You could set the rotation to 180 degrees, so you have one flat edge and it will sit flush with the wall. All right. So the next solid modeling tool in the family editor is the sweep tool. So just like other tools, it is sketch-based, but this time you can take that sketch and extrude it along a path that can be drawn. In this case, on the slide, we have a piece of base trim. And on the right, you can see the sketched path and the drawn profile and how the software will make that turn and leave a nice mitered corner. We can also do a curved path, and that looks nice as well. Maybe if we have time in our live Revit demo later, we can take a look at that. And now let's talk a little bit about voids. So those, like I said, those are the most common and practically used solid modeling tools in the family editor. But from there, we can add in voids for each of the tools that we already looked at. So that's what I was saying. There's, for every solid modeling option, there's a void counterpart. So this really makes it possible to do all sorts of creations. On the slide, I have a tabletop with eased edges. And in this case, I was able to model the tabletop as a rectangular extrusion. And then I created the eased edge as a void sweep. I took this one step further by using a special feature which allows me to select the edges of the extrusion. So if the underlying geometry changes, the hosted void sweep will adjust automatically. And no matter what the size of the tabletop is, it's going to maintain that eased edge. So those sketch lines will just stay associated with the picked edges and move right with it. Okay, so now that we have seen what kind of geometry we can model, what's next? Well, one thing we can do now is utilize the family types feature. This will allow us to have multiple iterations of similar items stored in one single component file. For example, I might have a window or door family where the overall design remains the same, but I have different combinations of height and width. This way I can load in the one RFA file into my project and then use any of the various family type combinations. In this slide here, we have an electrical panel. With it selected, you can see that I have several options to choose from for the different electrical requirements. The convenient part here is that all of the options have been saved to this one family file. All right, so here's another example of this. I made a schedule for one component family file. So it just lists one window family, but I have a separate line item for each individual family type. And notice that I can extract any parameter values I need that might be unique to each individual type from this family. Another thing that is super convenient is that I might need a new size while I'm working on a project. If that ever happens, I can easily make a duplicate of an existing one, change some parameter values, and instantly have a new family type without even opening the family editor to add the new type. So this new type can just live right inside your project file. Very convenient for new users who are not really familiar with the family editor yet. You could just create the new type right inside of Revit. So you might be thinking, okay, that's great, but what if I don't need every single option loaded into my file? The last component we looked at only had 4 family types, but some have dozens or hundreds. And if we loaded in every single option, that could really add unnecessary objects to the model, making it difficult to find what we actually need, and potentially could add a lot of file size. And this is where the specify types dialog box comes in handy. A lot of you have probably seen this when you load in a component such as the structural columns or beams family. You might see this type selector, and you can just pick and choose the ones you need. If you need a whole bunch at a time, you could use the control button to select each one you want, or the shift key to select a whole bunch together, just like standard Windows tool there. If I were to locate this exact same file in Windows Explorer, you can see a lot of notepad files associated with some of these RFA files. These are referred to as type catalogs. And these are where the actual family type information and their parameter values are stored. So if you have ever downloaded content from the web and it had a text document like this with it, that is what those are for. So just be sure that you have both in the same directory, and it should work fine when you load in your family. So just another look at this. Yeah, I don't recommend opening up these text files. In fact, these things are definitely not meant to be modified, but I think it's important to just kind of understand what they're doing, because I'm sure you've seen them before if you were looking at the content that came with the software. And these, like I said, are what make that specify types dialog box possible. And one other thing here. Yeah, so that's pretty much all I wanted to say about the type selector. Okay. All right, so one of the most powerful aspects of Revit software is how it organizes model elements into various categories. For example, if I place a door in my model, Revit knows it's a door. If I place cable tray, Revit knows it's cable tray. Now, the reason this is so important is because I can globally control things like visibility, scheduling, tagging, and material takeoffs based on the category, the overall category that the elements are assigned to. So I can globally control the way all of my lighting fixtures appear and things like that. For new users, it might seem like this all happens automatically, and to an extent, that is absolutely true. When we use system families like walls, floors, roofs, ducts, pipes, and conduit, the category is hard-coded and can't be changed. That is not the case with component families. Most of the elements that come out of the box will all be assigned to the correct category, but when you're creating your own content from scratch, you do have a couple options. If you are working with an existing model in the family editor, you can check its category setting via the family and category settings window. In this case, you can see this plumbing fixture has been set to plumbing fixtures. All right. Now, the other option with respect to categories is you can start your model from one of the family templates provided with the software. This will ensure that your model is already assigned to the proper category. Additionally, these templates have a lot of items preset for the various components you might be working on. If you, say, for example, start a new lighting fixture family from one of the lighting fixture templates, you will notice that it not only already has the categories set, but will have some planes, a light source, and some parameters all ready to go. Looking at this list, you might notice that there can be a lot of different options for the same category. And most of these have to do with hosted objects. All right, so what is a hosted object? Well, if you have ever tried to place a door or window, you might have noticed that you get that little no smoking symbol until you find a wall to use as a host. That is because walls and doors are almost, windows and doors are almost always wall hosted and cannot be placed without the proper host. Walls are just one of the many types of hosts in Revit. We also have ceiling-based elements, commonly used for lighting fixtures and air terminals. We see a lot of floor-based elements for various types of furniture and equipment, especially if the element will be cutting a void out of the host. You will need to use one of these templates. Now, a lot of the time, users will find it a little too restrictive because that means you can only host to those elements and nothing else. And that is when it might make sense to build a face-based component if you still need it hosted. And this will allow you to host to any face or surface, including reference planes. And this is a very popular choice for MEP engineers, especially when the architectural elements are not modeled natively in their file. You have already seen some examples today, and the plumbing fixture a few slides ago is now shown again, but in plan view, so you can see it hosted to a reference plane. So some astute observers might have noticed there was also a line-based option. Line-based families will actually let the user click a start and end point, and Revit will infill the geometry based on the imaginary line that would be drawn from the two clicks. For this, why don't we change it up a bit and see a live example in Revit. This way I can show some picks and clicks as well as elaborate on a few of the topics from earlier. So give me a minute to shuffle some stuff around here. All right. Get Revit going. All right, 1 second here. All right, so we're now inside Revit. And let's start with a look at a line-based detail item. So the one I want to choose here is, let's say I'm looking at a knee wall in section. And maybe just for my detail, want to model in a piece of gyp right here. I said model, but maybe I don't need it modeled. Maybe I just want to show it in this one detail section. So I don't need it modeled, but I'm working on my detail. I want to show it in there. So let's go to the Annotate tab, and we'll choose the Component tool. Now, from the Annotate tab, the Component tool will allow you to open up a special kind of component called a detail item. These are typically ones that are used for two-dimensional applications. So let's say I find my gypsum sheathing. And again, we're talking about line-based elements here. So I'll make my first click and then my second click, and it draws in the detail. Let me make another one of these just to kind of show you how these work. So click, click, and it draws it in there. It's maybe a silly example, but let me load in another one of these detail items. Let's say we need some plywood. Maybe we're doing a countertop here, or I can think of any number of reasons why I might want to just show some plywood, but I don't need to model it. So if I go to Insert, Load Family, got a lot of folders here. This is all out of the box. If you've installed Revit with the standard library, you should have all of this content, or at least access to all of this. I'm going to go to the Detail Items folder. And again, these will all be 2D. We'll do some more 3D in a minute, but for now, these are all 2D. They're broken out by division. I'll go into the Wood and Plastic folder, find sheathing. And here I've got something called a plywood section. Okay, great. That's exactly what I need. I'll open that up, load it in here. Go back to Annotate Component, pick my plywood section size, and start sketching it in. So make the 2 clicks, and that's it. There's my line-based option. Now that looks great and everything, but what if I want to backsplash here? So I can right-click and say Create Similar. Well, look at this. Hit the space bar to flip it in the proper direction. Well, now my plywood fill pattern doesn't really align here, and I bet some of you have noticed this before, and I've actually got an updated copy of this plywood family that I like to use. So this is kind of an upgrade from what comes out of the box, and there's not really an easy way to fix this. This problem is from the detail item is set with a let me rephrase that. It needs to be switched from a drafting pattern to a model pattern that doesn't come out of the box. So a while ago, somebody gifted me a copy of this family that was set to, and that immediately fixes it. So since I can't walk you through how to fix this, just for joining me on this webcast today, I'd be happy to share this updated plywood section with everybody. So if you are interested in it, when you take the survey today, at the end of the session, just go ahead and comment plywood in there, and I'll know to send you a copy. We might also try to find a way just to send everyone a copy. Just a little special thanks for joining me today. I wanted everybody to go away with something. Didn't want everybody to go away empty-handed. So that will be my gift to you. Okay, back to some of our topics at hand here. Let's take a look at that countertop family again. So I'm just going to switch over to a standard Revit project. And we were using that countertop family before for an earlier example. I'm going to place another copy of that in here, and we'll just talk a little bit about, dive a little deeper into instance versus type parameters. So for this, it's going to be a model component. So I'll go to the architecture tab and then go to the component tool. From here, it looks like I don't have it loaded in. So I'll click Load Family. And back out of the detail items and go to the casework folder, and then into the countertops and grab the standard countertop here. All right, if I load that in, let's just place one in Jerry's office here. So if I click on this, you can see I have access to the length parameter. That tells me that this is an instance-based parameter. So if I were to create a copy and put one into one of the other offices here, maybe we've got one in Bobby's office, you have the flexibility of changing this one without affecting the other one. We've also got the ability, since it's instance-based, to drag it on screen and adjust it there. Now, this is different from type properties. If I click on this, dig in a little deeper here. Let's go to the Edit Type dialog box. We have more dimension parameters, and the depth here is set to 2'1", and we know it's a type property because the name of the type is 24-inch depth. So if I did want to modify this or create maybe a 36-inch one, you could make a duplicate, name it whatever you need it, and then maybe change this to 3'1". And now we've modified this one. So we've now got a new family type right inside here. So hopefully that kind of clears up the difference between instance-based type parameters. Let's take a look now at some visibility items. These come up a lot in Revit. Let's go to our default 3D view here. Let's say I zoom in on this door. And I could change the level of detail setting here from fine to coarse. And when I do that, look what happens. A lot of my hardware disappears and some items kind of get more boxy. Like the detail just gets kind of not ignored, but just hidden. If we switch it back to a fine level of detail, you can see things like the hardware turn back on. You'll see the same thing in plan. Yeah, you know what? Why don't I show that in plan too? If I were to zoom in on that same door, and switch it to a coarse level of detail. If you're looking at the jam, it'll kind of make it a little more boxy. So that's one of my favorite features of creating content, is you have the ability to control what gets shown per level of detail. Now, if it's been a while since you've created content in the family editor, I want to do this. Let's click on this, open this up inside the family editor. Now, I've been doing this for a while. So back in the olden days, we used to have to load these back into the project environment every time we wanted to test and make sure our visibility settings were correct. But now, if you're looking at one of these elements, hopefully everybody knows this by now, but if not, there's a special new visibility mode called Preview Visibility. You can turn that on. Now we've got this yellow box around our window. So if I change my level of detail, it will mimic what you would see in the project environment. So that was a big upgrade, because whenever I was building content, there was really the only way to test it and make sure it was working properly was to load it back into the file. So this is one of my favorites here. So while we're doing this, yeah, I can click on this door hardware, and I want to point out a couple things about this. One, how did we set it so that it would turn off based upon different levels of detail? Well, if you look over at the visibility and graphics overrides here, we've got an option for one, looking at in plan. And in this case, it is always turned off in plan, but it's always shown with the checkbox turned on in front, back, left, or right views. And look at this. It's not shown in coarse or medium, but it is shown in a fine view. So it's really nice to have this level of control. One other thing, this door handle, this is not natively modeled inside this particular door family. It's actually a separate family that's loaded into this. And the term for that is nested families. Okay. So let's talk a little bit about materials. And while I've got this door open, I think we could probably use this. If I click on this door here, you do have the ability to assign a material to it, to this, because this geometry that I've selected, this is native to this family. You do have the option to assign a material to it, but the better option is to click this tiny little button here and assign a family parameter to it for material. What this will do is inside the project, let's go back to our 3D view. Inside the project, it'll allow you to have the ability to change whatever material you want, because otherwise you would have to go back into the family editor, find the material, or maybe even create it and then load it back in. Inside the project environment, you're way more likely to have access to tons and tons of materials. So if I select this door, go into the type properties, again, so this will be global for every family type here. If I've got maybe 20 of these on my project, if I go into the type properties, this is going to affect them all. But right here, I've got different material options and I can globally change it right here. Click on that button, find any other material that I want, swap it out, and now all my doors will have this new material applied to them. Okay, so let's see where we're at here. I think we're kind of, I did have one more thing I wanted to show. I've got this bollard family here. This is also a line-based family. Maybe I'll go back to my floor plan here. All right, so let's say I've got this bollard family, and over here's my loading dock, and I don't want trucks kind of backing into my wall over here. You can click to place, just like the plywood family. This is line-based, so it takes 2 clicks. Click once, click twice, and we've got our bollard family. Let's see what that looks like in 3D. That's the other side. Let's rotate around here. So if I click on this, these bollards are all nested inside here. And you know what? I've got an idea. Why don't we look inside here for a minute? Inside the family editor, basically it's a nested bollard light combined with an array. I had to do some tricks with parameters to get this going here. And in fact, you know what? I could probably build one of these from scratch while we still have some time. But I'll tell you what, I'm going to start working on that. And if you have any questions, feel free to start typing them. And yeah, I guess, Brett, I haven't taken a good look at the questions yet, but if any come in and we want to discuss any, let me know. Let's do this. I'm going to create one of these from scratch just to have a little fun here. And again, feel free to keep the questions rolling in. We'll kind of do a walk and talk here. So let's say I go to File, New, Family. I could choose any of these family types. Maybe I'll just do a line-based option. And you'll notice I've got a rig set up for me. It's got this reference line here. I could load in the bollard. I think it's in the site folder. That went too far. Oh no, lighting, I'm way off. Let's see here. Lighting, architectural, external, bollard light. So I'll load one of these in here. Click to place it. I can lock it where I want it to go. Use these reference planes in here, lock them down. Click on this one. Start the array command. This is pretty cool. Move to last. Make a click here where I want the last one to go. Doing a line, AL. Now, when I select this array, I can add in a new parameter here. So I want this to be an instance parameter because, you know, I might have one run of bollards with like 5 lights and one run with like 10. You know, you never know. So maybe we'll call this, let's see here. we'll call it, what should I call this parameter? Yeah, we'll call it number of bollards. And now if I go into the actual family types here, I have even more control. I could just determine the number that I want here, but I want a variable length. So I want it all to be based upon the length. So what I need to do is create an extra parameter here. So I go to new parameter, and maybe I want the minimum spacing to be like 4 feet, so you can get between them, but like pedestrians can get by, wheelchairs, but no cars. So I want it with a minimum spacing. So I'll have to create a parameter for that. Min bollard distance. This is also going to be an instance parameter. It's grouped under dimensions. I could put it under constraints if I wanted to. It doesn't really matter. That's user defined. Now, for the number of bollards, I could just say length divided by min bollard distance. Oh, I know my problem here. I didn't put the minimum length. Let's put that in there. There we go. So it calculates the amount we'll have here. So I'll click OK. Let's give it a little higher length. Let's see, where did I mess up here? That's okay. Let's see. Always something, always something. Oh, I changed the wrong length. Okay. There we go. All right, so that should do it. But now that we've completed this, let's test it out here. Let's do family types. Let's say I change the length to like 20 feet. And there we go. It adds them all in here. So what I would do now is just save this out to my library. And then I could load it into my project. Load into project. There we go. And now, so I've already got that one. It's really the same thing, but you can see now I've got the old one in here, also the new one. Let's do a search for it. Yeah, it's the old one. There we go. There it is. All right, so let's go back to our slide here. I got one more slide for you. Then we'll kind of wrap things up here. Let's see. All right, so now we really just scratched the surface of a lot of these topics today. And as advertised, this session was mostly an introduction. However, if you want to learn more, I would love to have you join me in one of our upcoming e-training classes. The 2-day BIM management template and family creation class spends an entire day of building content from scratch in the Revit Family Editor. We will walk through all of the picks and clicks and learn how to create any kind of content you need and incorporate a lot of what we talked about today. And contrary to the BIM management title, you do not have to be a BIM manager to take this class. We firmly believe that the content covered is essential for any Revit user. In addition to content creation, some of the topics will include in-depth schedules, view templates, view filters, and discipline-specific setup for your project templates. And as you can see, we actually have a class starting a week from today, as well as a class next month. And like I said, I would love to have you join me. It really is a great class. And you might be looking at your calendar thinking, hey, those dates don't work too well for me. And that is cool too. I know the holidays are coming up, and we will always be happy to add a class based on some dates that work for you. As long as we have 2 people, we can run a class open to the public. You might also be thinking, well, this is great, but my work is super customized, or you want a private class for yourself or your team. We can do that too. Just get in touch with your Hagerman and Company sales representative, or even let me know, and I can have them reach out. And we would love to have a call with you and your team and discuss your needs. We love seeing what you guys are working on and just like getting the conversation going or continuing. I'd also mention you can always keep an eye out for our social media, blog, and email list for announcements regarding classes offered, relevant and useful, and best of all, free articles and tips and videos and webcasts just like you saw today. So with that, we'll double check and make sure that there weren't any other questions. Let me go ahead and open that up.
Rick, there are 2 outstanding questions at the moment.
Sure, yeah, Brett, go ahead. Let's see.
I left them for you because I think they relate directly to the example you were doing. First question, how did you rotate the model the way you did?
Yeah, hey, Tom, what I think you were asking was when I orbited, how did I orbit? If that is what you're asking, when I was in 3D, for that, I just have a regular 2-button scroll wheel mouse. I pressed the scroll wheel down and then held the shift key. So left hand holding the shift key, right hand pressing or holding the scroll wheel, and was orbiting around. That's what I was doing there. Then let's see. Yeah, it looks like we had a question about the length being measured in the Ballard family. That was just the length between the clicks. So it's from the first click to the second click. That's what the length was going to be. All right. So I think, I've gone over a minute, so I apologize for that. But hey, everybody, I really enjoyed doing this for you. And like I said, we'd love to hear from you and love to have you in any of our upcoming e-training. So with that, I think, Ashley, if you'd like to wrap us up, that'd be awesome.
Sure. Well, thank you, Dan. And thank you all for attending today. Again, there will be a short survey that will pop up, and we do appreciate you filling that out for us. If you want your AIA continuing education credit, you can leave your number in question number 4 of that survey, and we will submit that for you. Also, just a reminder, everyone registered for today will receive an email tomorrow, which will contain a link for the recording so you can watch this again. And I believe that is it. So we will wrap up today, but thanks everyone for attending and have a great day.